Hello viewers, I am Dr. Mala Das Sharma. Welcome you to my channel Chemphilic. So let's start episode number 55 of Teaching Chemistry through Riddle. Here is our riddle number 55, which is an organic chemistry problem. It goes like this. X is an aromatic compound where a functional group is attached to benzene ring. If one more same functional group is introduced, then the second one occupies the meta position with respect to existing functional group and form compound Y. Out of two same functional groups of Y, one can be selectively reduced to form compound Z. The reduced group can be converted to another group A by nitrous acid, which can be replaced by many other functional groups along with the evolution of nitrogen gas. Therefore, compound Z can be transformed to X as well as Y via the formation of the group A. So, this is riddle number 55. Now, let's start our discussion. So, we'll do the discussion on the following topics. First one, identification of the compounds X, Y, Z and group A. Second one, outline the steps for the transformation of X to Y and Y to Z. Third point, outline the steps for the transformation of Z to X and Z to Y. And the fourth point, mechanism of the reactions involved. We'll discuss according to this point. Now, let us assume X is nitrobenzene. Now, we verify whether it is correct or not. So, this is nitrobenzene. That means this nitro group or NO2 group is attached to this benzene ring. Now, second clue was this nitro group. We know that it is meta-orienting group and it is deactivating group. And the second clue was that the same functional group, if it is introduced, it will go to the meta position. And therefore, nitration of nitrobenzene results the formation of meta-dinitrobenzene because nitro group is meta-orienting group. Why nitro group is deactivating group and meta-orienting group, that we'll discuss now. Before that, we'll see the nitration process. So, when nitrobenzene is treated with this mixed acid, that is the mixture of concentrated nitric acid and concentrated sulfuric acid, this is the nitrating agent, then another nitro group will be introduced to the benzene ring and it will go to the meta position with respect to this existing nitro group. So, the compound is meta-dinitrobenzene. This is our compound Y according to the riddle. So, this nitrobenzene, when it is nitrating, that means when the another nitro group is introduced by electrophilic substitution reaction, then meta-dinitrobenzene is formed. Now the question is that why this nitro group is deactivating group and why it is meta-directing group. Now let's see. And the deactivation of the benzene ring towards electrophilic substitution reaction. We know that in the benzene ring, the delocalized pi electron cloud is there above and below the ring. So, benzene ring itself acts as a nucleophile. So, it attracts the electrophile, that means electron deficient species. And it undergoes electrophilic substitution reaction where the hydrogen atom of the benzene ring is substituted by electrophile, not the electrophilic addition reaction. We know the reason, because if it undergoes electrophilic addition reaction, then this aromaticity is destroyed. That means stability is reduced. So it undergoes electrophilic substitution reaction where aromaticity is retained. That means stability of the molecule is retained. Now the question is, why nitro group is deactivating group? Any deactivating group means the key atom. Key atom means the atom of the group which is attached to the benzene ring. For nitrobenzene, this is the nitro group. This nitrogen is attached to benzene ring. So this nitrogen is the key atom. Key atom must be attached to another electronegative atom by multiple bond. That is the condition for the deactivating group. In the deactivating group, the key atom is attached to another electronegative atom. Here it is oxygen by multiple bond. Here it is double bond. So those are deactivating group. Deactivating means they deactivate the benzene ring for further electrophilic substitution. Then how they deactivate? Say for nitro group, it deactivates the benzene ring by withdrawing the electron density from the benzene ring through minus I effect, that is minus inductive effect, minus R effect, that is or minus resonance effect or mesomeric effect, and minus E effect, that means minus electromeric effect. With all this effect, nitro group withdraws electron density from the benzene ring. So electron density is withdrawn means benzene ring becomes electron deficient. When the benzene ring becomes electron deficient, then electrophilic attack is not taking place easily. That means the ring becomes deactivated towards electrophilic substitution. Now the question is, why this deactivating group direct the incoming group in the meta position? Now that we can explain from this resonance structure. Now see this resonance structure. Nitro group participates in resonance with the benzene ring, and through resonance it withdraws the electron. Now look at the resonance structure. This pi bond shifted here and this pi bond shifted to oxygen. So ortho position you are getting positive charge. Then this positive charge double bond separated by single bond. Then this electron pair moves here and you are getting the positive charge in the para position. Then this positive charge double bond separated by single bond, that means conjugation. Then this electron pair shifted here. Again you will get the positive charge on ortho position. So during resonance we are finding that ortho and para position positive charge. That means from this position electron density is more withdrawn. That means these positions are more electron deficient compared to meta position. Meta position also electron deficient because nitrogen atom is attracting electron density even minus I effect also. But compared to ortho para, meta position is something better, relatively better. So it occurs in the meta position. Further electrophilic substitution occurs in meta position. Now we'll see the mechanism of nitration reaction. Nitrating agent is concentrated nitric acid and concentrated sulfuric acid. So this is nitric acid. From sulfuric acid, H plus goes to this lone pair of oxygen of this OH group. Then this is the situation. Now this bonded electron pair shifted here because oxygen is positively charged, and then we will get NO2 plus, that is the electrophile. So first step is the generation of electrophile. Second step will be attack by the electrophile and formation of resonance stabilized cation, and then finally the product will form. Now this is the electrophile. Now from this benzene ring, this pi bonded electron pair, say through this carbon atom, it is shifted to NO2 group, and then this carbon atom becomes positive. And then this carbon atom and this double bond separated by single bond, so resonance participation will occur. So it will move here, then positive charge will come here, then this pi bond will move here, then positive charge will come here, like that. This resonance participation will occur. Next step, what happened? This hydrogen will remove dash H plus and this bonded electron pair shifted here. Then you will get the nitrobenzene and H3O plus. This hydrogen removed as H plus. So this electron pair shifted here, then this electron pair shifted here, then this electron pair shifted here. So you will get this nitrobenzene. So this is the mechanism. Now, in the next clue in the riddle, it is given that this compound Y, that is the meta-dinitrobenzene. In meta-dinitrobenzene, there are two nitro groups. One nitro group can be selectively reduced to amino group, and there is one specific reagent for that. Generally, nitro group can be reduced to amino group by using iron hydrochloric acid, then your tin hydrochloric acid. But for this selective reduction, there is a specific reagent which is sodium sulfide or ammonium sulfide, whereby one nitro group is reduced to amino group and we will get meta-nitroaniline, where one group is amino group. And this is our compound Z. Now, this amino group can be converted to diazonium group or diazonium cation. How? When this amino group, that means aromatic amine, here it is meta-nitroaniline, when it is treated with nitrous acid means it is generated in the medium by using sodium nitrite and hydrochloric acid at low temperature 0 to -5 degrees centigrade, then we will get this diazonium cation. And this diazonium group can be replaced by many other groups. That means from this diazonium salt, you can prepare a number of compounds. So it has a high synthetic importance. Now, let's see the mechanism of diazotization reaction. Diazotization reaction, here it is nitrous acid, that means which is generated by sodium nitrite and hydrochloric acid. This is nitrous acid, okay, and medium is acidic. Now what happened? This H plus will come to this lone pair of electrons of oxygen. So this oxygen becomes positive. So this bonded electron pair shifted here and you will get N double bond O plus. Okay. Now this electrophile N double bond O plus, here this is your aromatic amine, this one is aniline. Now the lone pair of electron of nitrogen atom of the amino group is shifted to this nitrogen. That means the nucleophilic attacks takes place to this lone pair of electron of this nitrogen atom of the amino group. And then what happened? This nitrogen becomes positively charged. So definitely H plus will be removed and you will get this compound, that is N-nitrosamine. Now, next what will happen? In next step, one more H plus is added to this oxygen. So, to the lone pair of electron of oxygen. So, what happened? Oxygen becomes positively charged. When oxygen is positively charged, this electron pair shifted here to neutralize it. If electron pair shifted here to neutralize this one, then it will be positively charged. So, this H plus is removed. That means here you will get the double bond. Again, the same step is repeated. Again, H plus is added to the lone pair of electron of oxygen. So, oxygen become positive. This electron pair shifted to oxygen. Okay. So, water is removed here. And again, this nitrogen will become positive. And so, this lone pair of electrons shifted here and form the triple bond. So, this nitrogen become positive. So, C6H5N, here N positive, triple bond N. This is the diazonium cation. Now coming to the next part of the riddle, that is the conversion of Z to X. That means Z is our meta-nitroaniline to X. X is nitrobenzene. So meta-nitroaniline, what you have to do? You have to convert this amino group to diazonium cation. When it is converted to diazonium cation, then this group, now if you want to prepare this nitrobenzene, nitro group is already there, then this group has to be replaced by hydrogen. How this diazonium group is replaced by nitrogen? The reagent is hypophosphorus acid in presence of glutathione. Then this group is replaced by hydrogen, and then already nitro group is there, you will get the nitrobenzene, which is your X. Next one is Z1, that is meta-nitroaniline to meta-dinitrobenzene. So this is meta-nitroaniline. Obviously, it has to be converted to diazonium cation. So here in meta position, nitro group is there. Now this diazonium group has to be replaced by another nitro group. Then what is the reagent? The reagent is sodium nitrite in presence of copper. Then this nitro group is replaced by this diazonium group is replaced by the nitro group. So we will get this compound, and in all this transformation, nitrogen gas is evolved. Now we have come to the last part. We will see what is our X. As we assume, all our clues given in the riddle that supported that X is nitrobenzene, and then Y is meta-dinitrobenzene, already we have seen, and then what is Z? Z is meta-nitroaniline, this one, and what is our group A? Group A is diazonium group or diazonium cation in triple bond N plus. So this is all about our discussion of this video number 55. Thank you.